Welcome colleagues and intellectuals to another video of the Mentico Mentor Gym. We'll look at the second part of our series, Chemical Bonding Exam Focused Questions and Answers, Part 2, which is dealing with hydrogen bonds. So follow me through as I tackle these questions one by one. Okay, so question number 1 reads, a hypothetical drug A is administered and binds on a receptor B, okay, to exert its effects, considering receptor B to be a carboxyl group, okay. So our receptor has a functional group of a carboxyl. Thus, react drugs A. If drug A includes aldehyde, carboxylate ion, and amine, okay. So for each of these hypothetical drugs, being aldehyde, carboxylate, and amine, we'll have to show hydrogen bonds between the carboxyl group, which is the receptor, and the drug, which is the aldehyde, carboxylate ion, and the amine. Okay, so our question 1 is aldehyde. Okay, so how many hydrogen bonds are formed as a result? So we'll put our receptor, which is of a carboxyl group. So this is our receptor, which is of a carboxyl group. Okay. This is the receptor we have based on the question. So from the question, we've been given that our receptor functional group is a carboxyl, and then we're reacting it with an aldehyde. So an aldehyde will present in this manner. Okay, yes. So this aldehyde group then interacts with this receptor. The question is, how many hydrogen bonds are formed as a result of this interaction? So let's define a hydrogen bond before we begin this exercise briefly. A hydrogen bond is a bond between a hydrogen atom and a high electronegative atom. Okay, so the bond that exists between a hydrogen atom and a highly electronegative atom is what you're calling a hydrogen bond. Okay, so from that definition, let's get the skill of identifying hydrogen and possible hydrogen bonds to be formed. Okay. So the presence of this hydrogen here is a possibility that a hydrogen bond can be formed. So from this molecule, we get this hydrogen, and from the other molecule, we try to detect for an electronegative atom, such as oxygen here. So one trick for all your electronegative atoms that possess lone pairs in this exercise, it's cardinal to show the lone pairs. So for those atoms that possess lone pairs, it's cardinal for us to show these lone pairs, for they will be the ones aiding the hydrogen bond. Okay, so show all your lone pairs. Alright, so this is the total number of lone pairs our electronegative atoms have. Okay. So a hydrogen then can form a bond with an electronegative atom through these lone pairs. So from this carboxyl group, we can form a hydrogen bond between these oxygen's lone pairs here and this carboxyl hydrogen, which is here. So that makes one hydrogen bond. Okay, and we still have another hydrogen below here, which is able to undergo a hydrogen bond as well with a highly electronegative oxygen of the carboxyl group, which is the receptor. So the lone pair can abstract a hydrogen and form a hydrogen bond, as shown. Okay. So from what we can see, there are no hydrogens left. So that means this is the total number of hydrogen bonds formed. So when we react our carboxyl receptor with our aldehyde drug, hypothetical drug, we realize 2 hydrogen bonds. So 2 hydrogen bonds is the maximum that an aldehyde drug can form after reacting with a carboxyl group as a total number of hydrogen bonds. So we have 2 as shown here. So we'll move on to our next molecule, which is the carboxylate ion. We'll do the same exercise, keeping in mind to show the lone pairs and the hydrogens. Okay. So we'll draw our receptor, just as we did in the first question, which is of a carboxyl group. By now, I expect the students, colleagues watching this video to understand function groups and understand their chemical structure. That's the skill we apply when we're dealing with such questions. Okay, so this is a receptor. Now, the second question is saying our drug, our hypothetical drug, has a group which is a carboxylate ion. So let's draw this group as well. Okay. This is our drug. Yes. Okay. So it's cardinal to indicate lone pairs for all electronegative atoms. So indicate all lone pairs. Okay, we can begin the exercise. So for us to identify the total number of hydrogen bonds, we have to identify hydrogen interactions with electronegative atoms. So this hydrogen here is able to interact with this electronegative atom, which is oxygen. So oxygen's lone pairs can be involved in a hydrogen bond. So one hydrogen bond can be formed here. Okay, so there are no hydrogen atoms present in this reaction. Hence, one hydrogen bond is the maximum number of hydrogen bonds a carboxylate ion and a carboxyl group can form when we're looking at drug receptor interaction. Okay, so one hydrogen bond as the maximum for the carboxylate ion. Let's go to our final drug, which is the amine. As usual, let's draw our receptor subtype, which is the carboxyl group. And we have our drug. Okay. So this is our receptor, which is the carboxyl group, and our drug, which is an amine. Okay, so we have our nitrogen bound to hydrogen and another hydrogen. Okay, so our amine is then going to react with this receptor and form hydrogen bonds. The task is to find out the total number of hydrogen bonds that the amine can form with our receptor. So let's indicate our lone pair. Each electronegative atom that possesses lone pairs, all the lone pairs have to be indicated for such an atom. So oxygen indicate the 2 lone pairs. For nitrogen, will indicate 1 lone pair. Okay. All right. So hydrogen atoms can now form bonds with these lone pairs of these electronegative atoms. So this hydrogen present on this receptor molecule can interact with the lone pairs of nitrogen, forming a hydrogen bond like so. So this is the first hydrogen bond as shown. Okay. So the amine as well possesses 2 hydrogen atoms, which can also participate in hydrogen bonds with some electronegative atoms as well. So this hydrogen from the drug can form a hydrogen bond with the oxygen of the carboxyl group. Okay, making us have 2 atoms engaging in hydrogen bonds. So we have 2 hydrogen bonds formed. We have our last hydrogen atom, which is also able to form a hydrogen bond with an electronegative atom, either of the 2 oxygens I'll pick this one to make it clearer. So this oxygen can participate in a hydrogen bond with our final hydrogen. This, ladies and gentlemen, intellectuals, gives us a total number of 3 hydrogen bonds formed as a carboxyl group receptor binds with a hypothetical drug which is of amine. Okay, so 3 hydrogen bonds as our maximum total number of hydrogen bonds in this question. Okay. Our second question reads, a receptor A is given to be amine group which is NH2. Draw a schematic showing hydrogen bonds with the following compound. Okay, so we've been presented with a receptor A which is of amine group. So this structure of our receptor is as follows. So we have our receptor which is of amine structure. Okay, so draw a schematic showing hydrogen bonds with the following compounds. So we'll have to react our receptor, which is amine, with the following compounds: carboxylic acid, hydroxyl, and a water molecule. Okay, so let's start with a carboxylic acid as our A. So we've depicted a picture of amine, and want to see how many hydrogen bonds will be formed when reacted with the carboxylic acid. So let's indicate our lone pairs. Okay, so nitrogen has a single lone pair. Okay, so the carboxyl group is as follows. Okay, and let's indicate our lone pairs as well. Don't forget, intellectuals, always indicate your lone pairs when dealing with hydrogen bonds. Okay. So all lone pairs have been indicated, and we can now form these hydrogen bonds. Okay. So this hydrogen is able to form a hydrogen bond with this oxygen. So this lone pair can participate in a hydrogen bond. Okay, let me just use a different marker to show the bond. So we have our hydrogen here participating in a hydrogen bond with this electronegative oxygen. So we use these lone pairs to facilitate this bond. Okay, so this will be our first hydrogen bond between the carboxylic acid and our amine. Yes. So this hydrogen participates in one, and this hydrogen is also able to participate in another hydrogen bond with either this oxygen or the other oxygen. So I'll participate in a bond with this oxygen. So this lone pair can be used to form a hydrogen bond between the receptor and this carboxylic acid. Okay. So both of the hydrogen atoms of the receptor have been bound through hydrogen bonds with an electronegative atom. So let's identify another hydrogen that hasn't been bound. Okay, so we found to say this hydrogen hasn't been bound. So this hydrogen is able to form a hydrogen bond with an electronegative atom such as nitrogen. So nitrogen will use its lone pairs to facilitate a hydrogen bond between itself and this hydrogen of the carboxylic acid. Okay, so this will be our third hydrogen bond. Okay, giving us a total of 3 hydrogen bonds. Okay, so when we react our carboxylic acid and our receptor, which is of amine structure, we realize 3 hydrogen bonds. Okay. So let's go to our second molecule, which is hydroxyl, and let's try to react this hydroxyl with our receptor, which is of amine structure. So I draw my receptor once more. Okay. Always keep in mind to indicate the hydrogen bonds the lone pairs, for they facilitate the hydrogen bond. So all lone pairs have to be indicated always. So let's show our hydroxyl group. So oxygen bound to a hydrogen. Okay. So as usual, we'll indicate our lone pairs. Oxygen has 2 lone pairs. Okay. So after indicating our lone pairs, we can now identify the hydrogen bonds possible between these 2 molecules. So this hydrogen can participate in a hydrogen bond with this electronegative atom. So this lone pair here can facilitate a hydrogen bond between this hydrogen, yes, and the nitrogen. So a hydrogen bond has been formed between these 2 atoms. Okay. And we still have hydrogens present in our receptor molecule, which are able to form hydrogen bonds with our electronegative oxygen on the hydroxyl group. So this hydrogen can participate in a hydrogen bond with this oxygen atom. So I'm showing a hydrogen bond formed as a result of a hydrogen binding to a very electronegative atom, such as oxygen. Okay. So we still have a hydrogen atom left in our receptor molecule, which is able to interact with a lone pair from an electronegative atom to form a hydrogen bond. So this hydrogen will also participate in a hydrogen bond of its own. Okay, so this will be our hydrogen bond. Follow it properly, guys, as I illustrated. Okay. So this will be our 3rd hydrogen bond. Okay. So thus we have no other hydrogens present to form hydrogen bonds. So the absence of hydrogens concludes to say 3 hydrogen bonds are the total number of hydrogen bonds a hydroxyl group and an amide group are able to produce when reacted. So the hydroxyl and the amine group produce a maximum of 3 hydrogen bonds. So let's take note of these bonds. And finally, we'll look at the final molecule, which is our water molecule, reacting with our receptor subtype, having a structure of amine. So we'll draw our receptor once more, and always include the lone pairs as usual. So all lone pairs have to be included in the schematic. Okay. And we include our water molecule. Okay, hydrogen, oxygen. Okay. So we want to find the maximum number of hydrogen bonds this water molecule is able to produce when reacted with an amine, okay, which is the receptor subtype. So this hydrogen present in this amine is able to form a hydrogen bond with this oxygen's lone pairs. So a hydrogen bond can emerge. We can have a hydrogen bond between this hydrogen and this oxygen. So this is our first hydrogen bond. Okay. So this hydrogen is also able to form a hydrogen bond with this nitrogen because of these lone pairs. So this lone pair can facilitate a hydrogen bond between the nitrogen and the hydrogen. So we'll have a hydrogen bond formed between this hydrogen and this nitrogen. Okay, that gives us 2 hydrogen bonds. So let's survey for any hydrogens and electronegative atoms left, and let's try to see possible hydrogen bonds that can be formed between these 2 molecules. So how we identify the bonding between the hydrogen and an electronegative atom is the presence of a free lone pair. So let's identify a free lone pair. So I have a free lone pair here, and let's look at the other molecule for a presence of a hydrogen. So we've got another hydrogen here. So the presence of a free lone pair and a hydrogen suggests a hydrogen bond. So there is a third hydrogen bond which is going to be formed as a result of this electronegative atom and this amine hydrogen being bonded together to form a hydrogen bond. So we have a maximum of 3 hydrogen bonds as a result of amine binding with a water molecule. Let's record our results. 3 hydrogen bonds as the maximum number of hydrogen bonds between a water molecule and our amine receptor. So this is the skill, comrades, we have to acquire after this exercise. Okay.